So for me, I'm not satisfied with this because of the score didn't get better. And so like I always like to kind of go back and try different things. And I think that's key. I think, we'll learn some additional techniques, but do note that, I mean, it's only going to change so much if you do change sort of the hidden layers. But, just to throw it out there, I mean, I might try something like this, 32, and then I want maybe more at the beginning, and then maybe a 4. And then let's see, is that similar? 425 parameters. And sometimes with just like one change. And then the other thing here is I may try like a little more of the validation set. And I think I would keep the rest of it and just like see how it goes. So let me just watch it from the beginning. I'm not necessarily going to keep it going, although you can always scroll ahead in videos. Yeah, look, it's not learning, so this one's not good. And what I tend to do is sort of tweak it. See, it stops, right? Because 1, 2, 3, 4, 5, no improvement, right? Slight improvement here. So you can see it's looking at the validation loss. So that was no good. It looks like those high number of, layers to begin with simply aren't helping. But what else could we do? Well, we could add what's called a dropout layer. Okay, so I guess we're getting into it with when you get the dropout, what that does is it prevents overfitting. So you take the dints and then you add a dropout. And then for the dropout layer, so now what you do is you say, hey, out of these, keep it with 32. Out of these 32, if I add a dropout layer, okay, do model.add dropout. And then what you're supposed to do with the dropout is, I think you specify the percentage. It's like, well, what's the probability that we're going to eliminate this node? And it might be something like 40%, say. So we're probably going to keep it, but we may just drop it. And this allows kind of to prevent overfitting. Then maybe we'll add one more dropout layer underneath the 8. And this time we'll drop it to say 20%. Okay, so now, and then we'll keep the rest. So now if we try it, in case this name dropout is not defined, I think I forgot to run this one. And try it one more time. And you can see the dropout is 593, but the dropouts aren't adding, they're actually taking away. Okay, and this randomization of dropping out nodes sort of prevents this overfitting. It means, if you think of those visuals, it's not forcing it to actually fit each time on all of those nodes. It's allowing for sort of more flexibility. Although you can see in this case, it's still not doing enough. So let me make a tweak here. Hopefully it's not from just this 15%, right? We want to be able to have a model that works well in different validation splits of the data. And, if I up these and maybe I take these down a little bit. Or what if I just match them and take this one out? See, I'm just experimenting with different options here. That's just part of the fun with neural networks, is you can try different solutions. So it's a lot more, but it's also more dropout. So try it again. Can we get learning to actually take place? Okay, it's starting better, and it is in fact learning. So I will let this one go. Hopefully you can see it's dropping pretty quickly. And so this is great. It's doing really well. Wow. It's uncommon to get like steady drops. And also we have an idea with this data, right, that once you get in, it's harder to kind of gain improvements once you get rolling. Okay, so this model will now continue to build until 5 of these validation losses in a row fail to show improvement. And it does look like it's starting to peter out a little bit, but again, you get these good ones and it shoots back up. So, you can imagine the way it's updating, right? It's trying to get under, like, can we get in the 140s? Can I get a 140? Can I get a 140? I don't know. Maybe not. And so what do we get? Still 103,000. So not as good, but you know, you've got more now that you can mess around with.